Different types of maps and different types of data associated with these maps. In general, these are called nominal data, ordinal data, and then these two numeric types of data, which would be interval and ratio. So if we have a single symbol, such as airports, for example, we can map that as nominal data. Every airport has a different name. If we have unique values, we can map that as ordinal data. That might be the suitability of a habitat, for example. Or if we have any kind of numeric data, we can make any sort of these maps with it. A graduated color map, a graduated symbol map, a dot density map, or a chart map. Here's an example of nominal data for airports in Oregon. So each one of these airports, symbolized by this airplane symbol, has a unique name associated with it, such as Roberts Field in Deschutes County. And that could be anything that you give a name to, an airport name, it could be a tax ID number or a county name. All of those things would be nominal sorts of data that would be stored in the data set and could be put on a map. So each feature is likely to have its own value, like the names of each of these counties here. And this can usually be portrayed with a symbol on the map, such as the outlines of the counties or the circles with the airplanes for the airports. So any sort of categorical data is going to have it's going to be mapping features, and it's going to have a unique value on the map. So this could be types of volcanoes, or highways, or as is shown here, different types of land covers. So each one of these land covers is represented by a different color. Each land cover is given a name, like urban and industrial, and where the urban and industrial is indicated by that same color on the map. Ordinal data is some sort of ranking, so good, better, best, or something like that. In this example here, we're looking at snail habitat and how it ranks. The whitest areas would be the most unsuitable habitat for these snails. The lighter green would be marginal, then the darker green acceptable, and the darkest green of all would be the ideal. So these are using unique values for the map, and you can see that this is just changing the color. It's making it from whitish to a dark green. So it's kind of going through a single color, but it's changing the value and the saturation of that color as we move from unsuitable to ideal habitats here. And interval data is going to be anything that has a numeric value, such as the elevation of Oregon. But the important thing is we can do addition and subtraction for this, but we can't do multiplication and division. So if it can have a negative value, it is an interval. Just like elevation, we could go below sea level and get into negative values here. But the important thing is if you were at an elevation of 1,000 feet and you climbed up to an elevation of 2,000 feet, you could calculate your change in elevation of 2,000 minus 1,000. So we can do addition and subtraction with these kind of numbers, and that's all fine. That's how we define interval data. So a numeric data that has a zero with numbers below it as well. For ratio data, that's a little different. It has a regular scale, but it has a meaningful 0 point. So unlike sea level, which can vary as the sea level rises or falls, population density, for example, a value of 0 means nobody lives in that particular area, in that particular county or whatever that area is. So with these types of values, we can do subtraction, addition, multiplication, and division. So all of those sorts of properties are possible with that. And once again, population density is a nice example here, right? We cannot go below 0 because we can't say there's negative people living within a state. So that would be an example of ratio data. And in this example here, we're mapping by bigger and bigger circles depending what the population density, what the population density in this case of the state capitals is.